Okay, so I think that I've got a triangle that's going to work properly this time. So we're finding the area of this oblique triangle, and we can see here that we've got an angle, and we've got the side opposite of it. And let's just go ahead for the sake of clarity and label these angles as well. So according to what I have drawn here, we have side length B, but we're missing two angles and a side. Now, in order to find the area of an oblique triangle, we have to look at our formulas and see that we need two sides.
Jansen and J.C. King to the high school office. Jansen and J.C. to the high school office.
We need two side lengths and the enclosed angle. And currently, we have two side lengths, but we don't have the enclosed angle. And we have an angle here, but it's not enclosed because we don't have this side length. So what we can do is solve the triangle and find the missing pieces. Now, in order to do that, we're going to have to use the law of sines, and we have to have a known ratio. So our known ratio are these a's right here. So I'm going to go ahead and set up 4 over sine of 45 degrees equals. Now, the only thing that I can find at this point is angle B. And this makes me realize that, oh, I've got the ambiguous case because I can't immediately solve for a third angle, which means that this is going to be a little extra work. So we've got 3 over sine of angle B. We're going to cross multiply and divide so that we get 3 sine of 45 over 4 equals sine of angle B. And remember, to get B by itself, we can't just divide by sine. We have to take inverse sine on both sides so that we end up with inverse sine of all this mess equals angle B. So now, let's go off and grab the calculator. Yay! And make sure my calculator is in degrees, which it is, and I'm going to type it in. So we've got inverse sine of 3 times the sine of 45, which we hopefully know is square root 2 over 2, all divided by 4, and we get 32.02. Since this is an angle, I'm going to round to the nearest whole, and I get B, it's approximately 32 degrees. But this is only B sub 1. Okay, there could be a possible other triangle out there. But before we go that route, let's go ahead and let's see if at this point now, can we find the area of this triangle? Well, no, because we're still not having two side lengths and an enclosed angle. So it looks like we're going to have to find angle C. So C sub 1 is going to equal or be approximately 180 minus 45 minus 32, which is 103 degrees. So at this point, we can find the area of this oblique triangle, right? But we're only able to find the area of this triangle. There might be a second one. Let's go ahead and determine if there's a second triangle before we move on. So remember, to find B sub 2, we have to check out what the angle is when we draw a reference angle of 32 degrees. Hopefully you're getting to where you might not even need to draw that anymore. But we're going to do 180 minus 32 and get 148. And I can already tell that this isn't going to work out because C sub 2 is 180 minus 148 minus our known angle of 45, and that's going to become a negative number. Exactly how negative, I'm not sure, like negative 18 or something. Negative 13. So that doesn't work out. So we only have one triangle, thank goodness. We're going to go over here and find the area. It's 1/2 our side lengths multiplied together, so 3 times 4 times sine of the enclosed angle 130 degrees. And that's going to be 12 times 1/2 is 6, and 6 times sine of 103 is 5 point, and it says 5.846. So if we round that to the nearest tenth, that'll be 5.8 inches squared. And we're done. So sometimes there's a little bit more work whenever you have to get two sides and an enclosed angle. But that's it for today. So hope you enjoyed your weekend and this video.